Hello, thanks for tuning in. This is a recording of an online training session, which was a beginner level class on the Node.js runtime. This was a freestyle, interactive, no slides, just me typing code and talking about it. So let me apologize in advance for all the speech fillers. I did, however, cut out the pauses and the not useful parts. So you can watch the whole training here on YouTube in one video. It's 2.5 hours, but it's also available at jscomplete.com/gsn19, where I split it by topic into many videos. You can also use the timestamps links in the description to navigate to the different sections. If you think of any questions while you watch this, please feel free to join the JS Complete Slack channel at jscomplete.com/help and ask us there. I hope you enjoy this class, and please share it with your network if you know anyone who plans on exploring Node.js. Let's get started. So this is a beginner class on Node. So no assumptions about what you know about Node. This is your first steps in Node. I might be assuming that you know a little bit of JavaScript, and I am definitely assuming that you know programming in general. So depending on your skills, you might be overwhelmed or you might be disappointed with the content. We all have different skills, and this is natural. But I hope most of you will learn a few things anyway. The class is recorded, so if you're lost in the class, go fill the gap in your knowledge and come back and watch the recorded class. So my name is Samer Buna, and I have been doing Node for a while. Currently, I do Node on the back end and I do React on the front end. But before that, I did a lot of other programming languages. I did some Tcl, Ruby, I did a lot of pSQL, but now it's all Node. So, and I am a really big fan of Node and everything, all the libraries that are added on top of the JavaScript language, which itself is very flexible and it can do whatever you want it to do. So if you want to see the stuff that I do, I put links here, feature links on this website, and also I publish everything I do on jscomplete.com. So there are video courses, books, interactive labs, and a lot more. JScomplete.com, by the way, is a Node project. So this is written in Node and React on the front end. So I have been hacking on this platform, and it's really fun. So Node is really fun. Well, at least for me. So let me set some expectations about the class today before we begin. So this is not going to make you an expert on Node, right? This is just your first step. So just to get you familiar, to raise your confidence in the platform, and to get you started on the right path to learning Node, because I think a lot of people learn Node the wrong way. They focus on the packages that comes with Node, or like the third-party packages that are very useful. But I think there is a big benefit into learning the internal, the raw runtime before you go and use the packages. And that knowledge is gonna make you make your use of those packages much better. So the one thing that you need for sure is you need Node. So if you have a Node version, let me make this a little bit bigger. If you have a Node version that is 10 or higher, you're fine. I think 8 will be fine too, but if you have an older Node version, so go ahead and install Node. I encourage you to always experiment with the latest and greatest. Always have at least the latest LTS release. But I actually do my development on the current version, even if it's an odd number, because odd number, they're not going to be LTS. So the way this works is even numbers are LTS, which is long-term support. Odd numbers are not. So right now we don't have any odd numbers. This is an even number, but it's not an LTS yet. It goes into LTS maybe in a few months, right? So LTS will become, Node 12 will become LTS, and they start with Node 13, which is not LTS. It's just experimental. But always try to have the latest Node so that you get to start exploring the new features that come to language, and so that you detect problems going away. Because once you have the latest, if you're using something that is deprecated, you're going to get warnings, and it's just so much better overall. But definitely, you have to test your systems on the LTS that you're going to use in production, right? So for example, jscomplete.com is running right now on this LTS. So even though I develop and I add features on 12.4.0, if I have it, I still switch things to the LTS and test things on LTS, just give the whole system a go on the LTS before releasing a big release. So there are tools for you to switch around. So if you're on Mac, you should definitely have Homebrew. Homebrew is just the best way to this one, the missing package manager from Node. The best way to install Node and install many other packages around Node. But there's also NVM. So NVM, and there's a version for it for Windows as well, is Node Version Manager. So if you have NVM installed, you can install Node and you can install different versions of Node, and you can switch between these versions with the press of a command. So you get to experiment with many versions of Node, and that's great. So what is Node exactly? So when you have the Node command, when you install Node, you get 3 commands. You get the Node command, you get the npm command, and you get the npx command. All of these comes built in with Node. So Node is a wrapper around V8. So V8, if you're not familiar with V8, V8 is the JavaScript engine, not the juice, the JavaScript engine, V8 JavaScript, the JavaScript engine that powers Chrome itself. So I am in Chrome right now. And if I go in here and open up the console and put in any JavaScript, so math.random, for example, this is a JavaScript function, this is a JavaScript standard library, and Chrome just executed that JavaScript. It did that through V8. So they extracted everything JavaScript from Chrome into this V8 engine. And of course, every browser has its engine, a different engine. So IE has Chakra, there's Spider Monkey, and a few of them. Now, this is different than executing a browser API. So for example, if I do document.getElementById, right, or get element by whatever, that is DOM API. That has nothing to do with JavaScript. It just have a JavaScript interface. So this is a JavaScript object, document is a JavaScript object, but getElementById is an API on that object. Same thing for things like set timer, set timeout, set interval. These are just functions that gives you access to the browser API. These are not JavaScript. So set timeout is not implemented by V8. It's implemented by the browser itself. So when you get the browser, you have two things. You have V8 that runs everything JavaScript, and you have the browser itself that runs everything DOM and scrolling. For example, a handle scrolling, a handle resizing. All of these events are coming from the browser. But here's the thing. Everything runs in a single thread. So if you have a big giant for loop in here that ticks for 1 billion times, that loop is going to block the browser from doing things like scrolling. So if the for loop is running in the background, the user cannot scroll your page. So it is important for you to understand that this is a single threaded environment. However, the browser gives you an API, asynchronous APIs, to do things asynchronously so that you don't have to block the single thread that you have. The exact same story is in Node. So Node, just like a browser, is also a wrapper around V8. So you get to execute, so if we have the Node command, just type in the Node command, Node, and you get into this mode that we call REPL mode, run eval print loop. And it's the exact same mode that you get when you open the browser's console. This is also a REPL mode. So in here, you can just do math.random, and you get the exact same thing. So this is through Node, right? But Node really didn't do anything here. Node just passed this command to V8, and V8 executed math.random. V8 told Node what the result of math.random is, and Node printed it to our screen right here. So it's going back and forth between Node and V8. So the question is, why can't we just use V8 directly? You can, of course, but Node comes with a lot of other benefits around the core standard library, right? For example, there is, let's say, an HTTP server. You can just start using an HTTP server. There is a package here called HTTP, and it gives you access to starting an HTTP server. And just like HTTP, there is a lot of them. In fact, let's take a look at all of them right away. So I'd like to point your attention to a very, very important key on your keyboard. Ready? It is the tab key, which is above the caps lock, right? This tab key is important because of the discoverability. It gives you discoverability powers. So for example, if array is a JavaScript class, right? And it has many methods. If you double tab on array dot, so just do array dot and double tap, you get everything that available on array. This is a great discoverability because I don't have to look up the things that it can do, especially if you have an object like a mystery object that you don't know what it is, right? So if I've give you M and you don't know what M is, you can just see all the methods that you can do look like M is an array because I get to join and split and keys and splice and reverse. So it is an array, everything I can do. And if you double tap on an empty screen, on an empty line, you get everything that you can start with. So all the JavaScript classes, you'll see here all the JavaScript classes because, you know, it's a wrapper around JavaScript, but also get everything that is Node. So you see HTTP, HTTPS, everything that starts with a lowercase letter. Most of the things that start with a lowercase letter here are built in Node. So libraries that just come with Node. You don't have to install them. Those are things that you can just start using. So Node is not a product from Chrome. Node is an open source, community managed project, but it uses a product from Google, which is V8. So V8 is Google. Google manages V8, and Node uses V8, and it uses other stuff, not just V8. For example, it uses OpenSSL and a few other libraries like that. Also, you can use Node with other VMs. So you don't have to, so there's an experiment or a project where you can use Node with Chakra, which is the Chakra core, the IE thing, you know, the powers IE Edge. So you can run Node without V8 using Chakra core. But by default, when you install Node, you get the Node that's wrapped around V8. Okay, cool. So this list here is really important. In fact, I would say if you want to master Node, you have to learn every single item on this list. I'm still learning new stuff because new stuff comes all the time, but most of this stuff is JavaScript. So if you are not familiar with things like date, function, not a number, errors, object, reflect, simple, these are JavaScript things. Weak map, modern JavaScript, right? Buffers array, integers array, floats array, map, promise, regular expressions, weak set. All of these are modern JavaScript that you get to use out of the box with Node. And the other stuff that I'd like to point out, so the things that we will explore today, so console is the same library, that the same object that you have in your browser's console, and they try to mirror the exact same interface for it in Node. But console is Node, it's not V8, it's written in Node, and it's in the browser. It's not V8, it's the browser itself. So today we're going to talk about console. We're going to talk about the module object. We'll mention path, we'll mention timers. We're going to talk about timers in general. We're also going to talk about HTTP, maybe a little bit of net. So there's a question, what is NPM? How is it related to Node? We're going to talk about that. So you're running Node.js on shell on Mac. What I should run on Windows? Command prompt? Yeah, so on Windows you can run the CMD. I would recommend that you, instead of CMD, that you install PowerShell. So PowerShell in Microsoft is just a much better terminal than CMD. And by the way, there is a new terminal coming to Windows, so that is going to be much better, right? But PowerShell is the way to go for now. What is the IDE tool called? The IDE that I'm going to use is called VS Code. So it is probably the most popular editor. So if you want to run anything, and we're gonna use it today, and I would recommend that you use it. In fact, on Windows, VS Code will give you a better terminal, so you can use the terminal in VS Code instead of using, the command prompt or anything. All right, what is iTerm2? So iTerm2 is just a replacement for the built-in terminal. It's just a little bit better than the built-in terminal, has better tmux integration, but you don't have to use it. But put it on your list, explore it. If you see Node is not a recognized command, that means you have to fix the path. So you have to put the node that was installed in the path. So we talked a little bit about Node REPL, right? Node also is a command line tool. So if you do Node-H, you get everything that you can do in Node as a command line tool, the CLI of Node. So this is the CLI that's going to run a script in general, but it also, you can use it with other options. So you'll see the usage here, Node options, and then you give it a script if you want it to run a script. Another usage is Node inspect. We'll talk about that, how to inspect a script in Node. And all of these options, just scan through them. They're handy. I'd like to point out one particularly or a few particularly helpful options. If you want to check the syntax of a Node file and not run it, just check the syntax, -C. If you want to execute, don't use E, use P, because P is execute and print. So I'll show you, let's explore that. So if I have Node-P, and you just give it any JavaScript, and it will execute it and print it right away. So -P is for print. Handy to just do things really quick. And the other one that I'd like to point your attention to is V8 options. V8 options. So if you do --V8 options, what you get is a big list of all the options that Node can pass to V8. So let's explore that. I'm gonna pipe it on less so that we get it page by page. So V8 options. So in here you're gonna see a lot of things, right? You're gonna see harmony flags, you're gonna see tracing flags, and this list is like 400 or 500 options that you can do. And these are options that Node pass directly to V8. So if you wanna change the way V8 behaves, change the or a little bit optimization of the way V8 behaves, or change some experimental flags, right? If you want to experiment with WebAssembly, right here, there's a flags for WebAssembly. So most of these options are actually advanced. I just want you to know of them, so you can come to these options and search if you're looking to do something particular with V8, like something advanced, like for example, if you're to work with the garbage collector in V8, right? V8 has a garbage collector. You have some options here to control the garbage collector, to expose the garbage collector, to manually run the garbage collector. So you'll come here and see all the options that you can do. All right, cool. Another thing that you should be familiar with is Node environment variables. So when you run a Node process, right? When you run the Node command, whether you put in a file or you just run it with, the REPL mode, what I did here is I started an operating system process, right? A process with a process ID. And Node exposed this process object. So there's a process object that has a few methods, a lot of methods actually. And this process object is basically the interface between your Node environment and the operating system environment. So if you need to read anything from the operating system, or if you need to write anything to the operating system, then you use this process object. So it's the interface. So this interface, for example, exposes the environment variables. So all the environment variables that you have in your system, just with process.env. This gives you access to everything in the environment that you have, which is a cool way to customize your Node session. So you just put something in the environment. Hopefully I don't have any passwords in here. You put something in the environment and you can just access it in Node, right? including things like, including the built-in environment variables. So the built-in environment variables are special environment variables that if you set them, then you get to change the behavior of Node. However, before I talk about that, let me show you how to control the environment, because this is important. So let's say node-p, and let's print process .env .user. User is a standard environment variable, right? So this is the user that I'm using. If you want to change that, all you need to do is just specify a different user, right? And Node will just use a new value that you put in here instead of the set in value, because I changed the environment variable before executing Node. And of course I can do export or set on Windows to change it forever. You cannot change. So this is a very good question from Amit. You cannot change the environment variable through process.env. It's a read-only thing. Although you can actually change it. So you can do equal test, but this will not change the environment variable here. So if you do that, right, and try to echo $user after that, it did not change it. So Node will not tell you that, oh, you can't change it. It's not really immutable. But you get a copy. You get a copy of the object. All right, so let's keep going. If you want to change some kind of behavior, I'd like to point your attention to a few of these environment variables. One handy in particular is Node debug. So if you use a library like, for example, HTTP, and you'd like Node to debug more information about what it's doing in HTTP, you can do something like this. You can Node debug, I think you just do HTTP, and then run your Node command, and this will tell Node to debug more information when it uses the HTTP library. So very handy when you start running into problems. You can change the path. So this is another important one that we're going to talk about. We're going to actually talk about that next, is how to control how Node discover modules. So let's go ahead and jump into the more serious mode, which is to run Node to run a script. So I'm going to create a directory. So Node, I'll just do 0619, and I'm going to go into this directory, not this one. And I'll just run VS Code on this directory to start exploring things. And let me just do everything in VS Code. So let's see, I'll have the terminal in here, VS Code, and I'll make it bigger. So if you have VS Code, you can use the terminal, the built-in terminal. Otherwise, you can still use the other terminal. So what I'm going to do is I'm going to create a file in here and call this file index.js, and we'll start exploring things in index.js. So don't worry about ESLint for now. So in here, you can do anything that we just did. So you can do math.random, right? And now math.random, and you can execute this file. However, it will not output anything because it just executed a value. So this is not REPL Node. So if we execute node index.js, it will do nothing, output nothing, because we're not in REPL mode now. We're in script execution mode, which means if you want to output something to the operating system that's running the process, then you have to use the interface to the operating system. For example, you can do process. So process.std out, don't worry about the syntax, .write, and in here you would do math.random, and it will probably not work because write expects a string. So let's try that. I think it will not work. Yep, it did not work because write here expects a string. So what do? Well, you can change this to string. So in here, what I did is JavaScript. This is a JavaScript expression. I just made it into a string. Let's make sure this is working. Yep, this works. So this is a JavaScript expression, right? And I fed it to a Node API. So this is a Node API. Process.stdout.write is a Node API. Now, Of course, this is very raw, lower level because you have the console object. The console object is also supported. So I can do math.random through the console object, and that is going to output it as well. And it's a lot easier. I didn't have to cast it into a string. I did not have to put a new line after the output. It actually colored it differently. So console.log is another Node API. And actually, if you go find the source code for console.log for Node, you'll find that it uses process.stdout.write. So there are many ways to do things. There are lower level APIs and higher level APIs. What if you console.log an object? What if we console.log process, for example? Process is an object. What's going to happen? Well, it's gonna print a huge. This is the default behavior for console.log. It will print a huge object and go through all the nesting. So everything that you can do on not just the first level properties for process, but everything in it, including arrays and all the environment variables, right? So this is not a very handy output. What do you do to make it handy? Well, you can use other higher level APIs. For example, the dir one might be a little bit better. The dir one is exactly the same, but the dir one accepts depth, I think, or like it accepts an object, and in here you can say depth is 0, I think. So let's try that. Yeah, so it gave me only the first level, so without any nesting. What is the first level of properties that you have on the process object? So this is a cool trick where you can start exploring. So it did not expand the big things that you have in process. So this is me executing a script, right? So we're going to talk about how Node does this magic. How does it execute a script? Can you turn on debugging for all libraries using Node debug? I don't think so. I think you can have a comma separated list. So you can do like fs and path. But usually you want to debug one library, because if you turn on everything, there will be thousands and thousands of debugging lines, and it's not really helpful. All right. So I am going to ask you a question, and let's pretend that we are in an interview and I'm interviewing you for a Node position. So I'm gonna ask you an interview question. I am gonna, so you know about the function x, right? And function x, and we're gonna call it, and function x is gonna console.log arguments. So arguments is a special keyword that present everything that you pass to x as an argument, right? So let's pass x 3 arguments, so 1, 7, and 9. So what is arguments in this case? If I execute this code, it will be 1, 7, and 9. Now you'll notice that arguments looks like an object, not an array. That's because arrays in JavaScript are just objects. They're just special objects where the properties are numeric, just like that. So this is an array. All right, cool. So you understand that, right? Now my question is, what is going to happen if I just console log arguments without any function? What is the output in this case? So that's your first interview question. Tell me, what is the output in this case? And if your answer is going to be undefined, you're going to be surprised. Arguments in this case is another array. There is an array here with how many arguments? With 5 exact arguments. So what are these 5 arguments, and why is arguments working here? Arguments is something that you get in a function, right? Why is it working top level? We're not in a function. And what are these 5 arguments that you get? This is core knowledge in Node. So the reason arguments worked is because Node has this concept of wrapping modules, right? So this is what it does. It wraps your code in a function. So you get this iffy by default. Everything you do in Node gets this iffy. Iffy is immediately invoked function expression. Immediately invoked function expression. So you get this iffy by default. Node just does this wrapping automatically. And it also does other stuff. For example, it returns something from your file. We're going to talk about that. But just in general, I want you to know that you get this iffy by default. This is why arguments work. So kind of like this, Node has this iffy and executed it immediately. That's what you get. And the arguments that you get are, one of them is module, one of them is exports, one of them is file name and their name. So let's actually take a look at them real quick. I think I'm missing one. Yeah, so require is the first one. Exports is the first one. Yeah, exports is the first one, I think. And then you get require, and then you get module. Exports is the first one, then require, then module. You can actually take a look at them. If you just do, if you require module, you can take a look at the wrapper. Require module dot wrapper. You see that? Require module dot wrapper. Require module dot wrapper. So this is exactly what you get. Exports, require, module, file name, and their name. This is the actual wrapper that Node uses. It's exactly that. All right, cool. So here's the thing. If you have two files, right? So we're gonna have another file in here, index1 and index2, index1 and index2.js, and I'm just gonna split down. All right, so you've got index1 and index2, right? What I want you to know is that every function, every file that you initialize gets this magic iffy, right? So if I console log exports in here, right? Exports is something that you get from the arguments, right? And I console log it in here. These exports are different, right? They're not the exact same object, although if you execute them, they're exactly the same. It's an empty object, right? But this empty object, index2 save, this empty object that you get in index2 and in index1, these are different objects. They're not exactly the same object. Why? Because they're coming from an argument that Node passes to your iffy function. So that's important. So all of them are different, right? Exports, require, module, file name, and their name. File name is, of course, the name of the file that you're executing, and their name is the name of the directory where your file is that you're executing. So you need to learn about exports and require. These are two basic things in Node. This is the Node, module dependency system. So next we're going to talk about these two. In REPL mode, you don't have arguments because you're not really executing a file. This is when you execute a file. This is how Node manages files and modules. How is console log working when you run Node file name as console log is available only in browser? Yes, console log is available in Node. So Node tries to mirror the browser's API, right? So when it comes to input and output, not DOM. So there's no DOM. You can't do document. You can't in here. You can't say, oh, look, anywhere really. You can't say document get elements by ID. That is not going to work. Why? Because you don't have DOM. So this will tell you undefined, some kind of error. Document is not defined, right? So it's not exactly the browser. However, Node opted to implement things like console, like set timeout, and a few other things that exist in a browser environment, but they're not JavaScript, right? So these APIs are built in Node, and their implementation is different than the implementation of the browser. And V8 has nothing to do with them. V8 is just gonna organize the execution of functions and callbacks, but these APIs are Node. Cool? That's why. So if you go grep the source code of Node, you're gonna find a console object and a log function in the Node source code, right? Not in V8 and not for any browsers. Okay, cool. Good questions. Keep them coming. So we're learning about this iffy function, iffy wrapping function, right? Cool. So what is exports? Exports is an object that you can change. So exports is a mutable object. So we can say exports dot answer is 42. And you can put any number of properties on exports. And when we execute this file, export is going to be whatever you define it. So it's just a special object that is available globally for you. It's also an alias to module.exports. So if I do module.exports another answer, then I am changing the exact same property. So you see how I changed it here and I changed it there. So exports is just an alias to module.exports. Cool? And here's the thing. Node, when it manages a file, it returns module.exports. So whatever you put on exports, that would be the return value of the index file, the index module. Now, why is this handy? Because another file might require your module. So let's call this module 1. This index is your module, right? And you want index 2 to use your module, to use index. What you do is you require it. You just use require and you pass in a string and you say index 2 is going to require index 1.js. Just like that. Index 2 is going to require index 1. So note what's going to happen. And in here, I'm not going to console log. I'm just going to console log. Let's console log in index.js, right? Let's console log in index.js. So just by requiring index, if I execute index2, what's going to happen is Node is going to look at this, find require, and it will require this file. So it will execute this file. So I'm going to get the console log message, although I'm executing index2. So that's the story of require. But here's how it's helpful. It's helpful because require gives you access to whatever this module.export things is returning. So whatever you put in module.export, you get it in here. So in here, you get an object, index, I'm just going to call it index, and I'm just going to log index. So guess what index is going to be? Index after index in index.js, this here, you get the exported module. So this is module.export. So whatever you put on module.exports or its alias exports, you get it out when you require a file. So require is dependencies, module dependencies. It's similar to import and export in JavaScript. In fact, you can also use import and export, and I'm going to show you that because this is new. This is new in Node. You get to use exports and import as well. So any questions about require and this exports business? Because that is core knowledge. All the packages out there that are written for Node, they use this syntax. They use exports and require. All right, cool. So I'm going to clean all this and just console log hello. And in here, I am going to require index.js, and I'm going to execute the file that's requiring. So this will output hello, right? Cool. Here is your second interview question. What's going to happen if I do that? If I require index 3 times, what's going to happen? So go ahead and try and answer. This will output hello 1 time. What? Why did it output hello 1 time and not 3 times, right? And the reason is Node has this require function in Node has some magic caching. It doesn't evaluate the file every time you require it. It evaluates it once, and then the second time it reads it from the cache. So this is why in an application, say it's a React application or an Angular application, you require React all over the place. You require Angular all over the place. Multiple files are going to require React or Angular or Vue, and only the first require is going to actually do the work. The second require will just read it from the cache. Well, another interview question is, what if I do want this file to console log hello every time I require it? And the answer is you really can't. You require, you get cache. That's just the reality. However, you can delay what you execute in the file by making it return a function. So remember module.exports, right? Module.exports is our API. So instead of having the file console log directly, you can have it export a closure. You can have it export a function closure, and you execute that function every time you want it. So if I make module.exports into a function, and I'm going to use arrow function in here, but you can just use a regular function, and I make this function console log hello instead of that. Now I have delayed execution. Now every time I require index.js, what do I get? Every time I require index.js, I get back a function. It does not have any code. It will just cache the function reference, and I can just execute this function that I get back from index.js. So if I do that and I execute this, I get hello 3 times. So we use this trick a lot in Node. We make the module export a function, and we execute the code in that function. So it's kind of a little bit of delayed execution. What gets cached is the function itself, not the function execution. Cool? All right. So there are many cases where you want to execute something in a file multiple times, right? So this is how you do it. You always execute a function. In fact, if you need the file to have multiple capabilities, what you do is you make it export an object, and in the object you have your capabilities. You would do like function 1, function 2, function 3, right? So this is another way to export API. So how would you do that? How would you invoke function 1? Now what you get back is an object, right? It's not a function, it's an object. And because it's an object that has f1, I can do .f1, right? .f1 because it's an object, and execute f1, right? And this will work as well. So whatever you put in here, this require is just going to use it, right? So, and you can put anything, right? You can put primitive values, you can put arrays, objects, or you can have like a proxy, anything that is supported by the language, you can use it as the exports value in your module, and you get to use it exactly as you define it, right? Whatever you have. We have an object that has an f1 property, so I'll just get the f1 property, and then because the f1 property itself is a function, I can execute f1, right? So there's nothing magic in here. It's just JavaScript mixed with the API that Node gives you to require functions. Now, this is a little bit different than the import-export syntax that is native to the JavaScript language, right? This module require business is Node's way to do module dependency, and it existed since day one in Node. So like 10 years before JavaScript decided to have a module dependency as well. Now, the problem is you have two systems. One has been used for 10 years and a brand new one that everybody is going to start using because it works in browsers as well. So what do? Well, here's what you do. You really understand require module.export. I understand it really good because you're going to have to deal with packages that are written in this syntax for at least 5 to 10 years into the future if you're working in Node projects. But in your own if you're starting a Node project today, I would recommend that you use the import-export syntax, not the require syntax. Now, they have different implementation, and I'm going to tell you about that in just a little bit, just so that you're aware. But I'm going to show you the import-export syntax first. So let's go ahead and do that. So let's do this exact same example, but instead of working with require, let's do it with import and export, right? So here's the thing. If you have Node 12, right? If you have Node 12, you can use import and export out of the box. It's actually supported. But remember that it's not LTS. So Node 12 is not LTS yet. Let's see, NVM ls. System, Node 12. So NVM use system. NVM ls remote. While we're talking about it, I'm just going to get the latest and greatest node, which is v12.14, and I'll use that. So nvm install this thing, and this will install the latest. So what you do here is you create a package.json file to start managing your dependencies, right? Let's actually name this M1 and M2 because they're kind of different. So M1 and M2, and I'm just gonna call M2 in here M1, right? M1.js, M1 and M2. So exact same example. I just named them M1 and M2 instead of what I had before. All right. And you can run them with the latest node. So this syntax is not going anywhere. So although we have node v12 now, we can still run M2 and we get the exact same behavior. So export and require is exactly the same. But what I'm gonna do is I'm gonna change this into import and export. But to do that, I need a package.json file. So what is a package.json file? A package.json file is a file that you can use to manage meta information about your node project. So every node package out there has a package.json file to tell you its name, its version, its Git repository, how to run things in it. So you create a package.json file with the npm command. So what npm is the node package manager, and we're going to talk about it in the next hour after the break. But for now, the first step is to use the npm init command to create a package.json file that we can use to control things in Node. So npm init, and this will ask you a few questions, or it can detect if you do -y, which is for yes. It says just try to detect whatever you can detect from this object and just give me a package.json file. So this will create a package.json file using the name of the directory, using a default version. It will try to find, if you have Git installed, it will try to find the Git remote that you have. It just detects a few things. So in package.json, you get to specify information about your package. So for example, if you put your name on the package so that when you push it, people know. If you want to have keywords so people can find your package in the search, you can use this meta information. So there is a new, and by the way, the only two required properties in package.json are just name and version. These are the only required. Everything else is optional. So the new property that you can use here on package.json is the type property. And if you specify your type as module instead of common.js, so the other one I think is common.js, which is the name that we use for the require exports thing. But if you specify your type as module, then Node will switch gears and just assume that you're just going to use your ECMAScript modules all over the place. So there's no require and exports. In fact, I think if we try to execute it now, it will not execute. It will not be happy. It will say, well, I actually executed that. Did this not work? Oh, we need a flag. So we need the experimental modules. There you go. See, so this flag is actually gonna go away when Node goes into LTS. I'm not sure when they're gonna remove it, but they will remove it. But this is how Node is gonna behave when it switches to the ECMAScript, the ESM module loader. See, this is now the ESM module loader. So it tells you I don't know require because I'm assuming that you are in an ECMAScript module, right? You're not in a Node module, you're an ECMAScript module, which means you cannot use exports, you cannot use require. So what can you use? You use export default. And in here, you pass in the object that you'd like to export. So it's kind of similar to what you did, but in here, we have a little bit of different syntax, export default. So instead of module.exports, you do export default. And instead of require, what you do is you import. You use the import keyword. So import m1 from ./m1.js, right? Import m1 from ./m1.js, and now you get to do m1.f1 and execute that 3 times. So you'll see a little bit of different syntax, but it's basically the same module dependency. So this works, right? You get a warning that it is experimental, but it's really just it works fine. They're just making sure that the API is stable. So it is the exact same thing, except there's no require, there's no module.export. Cool? Now we have a big question. What is a module? So that is an important question. What is a module? So I'm going to give you the short answer, and I'll give you the long answer after the break. So the short answer is a module is just a file. is just a bunch of lines of code in a file, but it can also be multiple files, right? And we get to now we need to understand what happens when you require or import a module. I'll just use import in here. What's going to happen when you import not a local file? So in here, what we imported is a local file, right? M1. What happens if you import, say, HTTP from HTTP? What happens if you do that? Because this is not local, because there is no, this dot slash means a file on the same level. Try to find a file on the same level, or a folder on the same level. So if you don't have dot slash or dot slash, that means go find this in a special somewhere. And this special somewhere is what we're going to talk about next. It's called the Node modules directory. And I want to tell you how Node modules tie in to NPM and other package managers and how things work magically. Now, HTTP is a built-in module, so it doesn't really go and look for it in the Node modules directory. It just take it from the built-in core that comes installed out of the box with Node. But if you do import from Express, for example, which is a package that you can use to replace HTTP, then you need to have Express installed. This is not a third-party package. This is not a built-in package. It's a third-party package. So you have to install it. You have to let NPM install this before you can use it. So we'll do that right after the break. So can we have a library of components and import it as a module for another project? Definitely. The answer is big yes. That's how Node works. In fact, when we import HTTP, what we're importing is a small library of things that we can use. And you can explore this right away by console logging HTTP. So let's take a look at what we get when we import HTTP. And in here, we're just going to execute M1 from now on, M1. And you get a library, a little library object with a few methods. So there is status codes, for example, all the HTTP status codes are here. So if you want to look them up, all you need to do is http.statuscodes. You get a few important methods and objects and classes in here. And the most important one is create server. So http.createServer creates an HTTP server. That's what we're going to use next. If you have Node 10, this is not going to work. What we're doing here, import HTTP, is not going to work. So you have two options. Either upgrade to Node 12 and use that, or you can use the ESM package. And this is how you do it. You npm install ESM, and this will download ESM from the internet and place it under a Node modules folder. So we're going to talk about that in just a little bit. It places ESM under a Node modules folder. You see that? And what you need to do to run things with ESM is, instead of experimental modules, you do -r ESM, -r ESM. So one more time, -r ESM. So this will work on Node 10 and 8 and everything. It's just a shim around experimental module. So you don't need Node 12. And it works actually really good. So -r ESM. So two new things just happened. We use the -r flag. What is -r? So -r is you require a module before you execute your code. So -r is kind of like a wrapper that you can inject a module into your system before Node executes your actual module, which is m1.js. So that's -r. And ESM is just a package that we downloaded. So we can now import ESM from Node modules. So before we talk about HTTP, I wanna talk about Node modules, right? So if you import, let's say you want to import from or just import, and you pass in something, you import something, right? What happens here is when you import something, Node looks at something here, the something string, and it figures out that this is not a built-in library, right? It's not part of the built-in library. It's also not a local file because it doesn't start with // or // So if it starts with // or // that means it's a local file. Go find it locally where we're importing. But because it does not start with dot or // that means it's not a local file. So Node by default will tell you that I don't know what something is. I cannot find module something because it looks under Node modules. So it tries to find something.js under Node modules. So if we go to Node modules and we put something.js and we put anything here in .js. So this is just a test. So what I did is I put something.js under Node modules. And guess what? Now, because I am importing something and there is a something.js under Node modules, it will find it. So there's no magic here. It just looks for things under Node modules. That's what Node does, right? And you can actually make this into a folder instead of a file. So you can have a folder called something. Under Node modules, you can make a folder and name it something and put your code under this folder. And by default, Node looks for index.js under the folder. So just a test here from a folder, right? And if you import something here, right, I can import the folder, and Node will look for the index.js file under that folder. And that's exactly how Node resolve your external dependencies. So if we npm install Lodash, for example, if we npm install Lodash is a JavaScript library that you can use. It has a lot of cool utility functions that you can use that are missing in JavaScript. You can use them. So what npm does is it just places, let's refresh this, it places Lodash, just like I did for something. It places Lodash under your Node modules directory. That's what npm does. It has nothing to do with import and export. It just downloads Lodash and put it under the Node modules folder in your project. Then here we can import Lodash because it is Node module. It is under Node modules, then it is something that I can just import. And import directly means just execute. So I'm not really interested in anything that the library returns, like whatever the library exports, right? But if you want to use whatever the library exports, then you have to give it a name. Usually Lodash, we do import underscore from Lodash, and now we get to do use the Lodash functions. For example, we can sum an array. So this is 1, 2, 3, and it will sum an array. Of course, we need to console log that. So you want to put it in a console log M1, and it is not working. Is it? Oh, you gotta put in an array. It doesn't sum an argument, it will sum an array. Okay, cool. So this is how we use external libraries. We use npm to download them and place them under the Node modules folder. Then we use Node package management to import them into the project and use their API in the project. That's the story of Node packages and how to use them in general. How do I make my library available for people to use it as imports in their project? Very good question. What if our something.js turns out to be handy and we want to make it available for other people to use it? What we do is we publish it under npm. Now, or we publish it under a repository in general, right? But if I want to publish my something.js, all I need to do is I need to make it have a package.json, and then I can just npm publish this thing, npm publish. Now, to publish to npm, you have to have an account with npm and npmjs.com, right? And it has to be a valid package, and you have to have the right to push to this package. If it's a new package, if npm doesn't have a package named something already, so the name is unique, then it will allow you to push it. But if you're trying to push to a package that exists, you need to have rights to it. So they need to add you as a contributor to that package. And of course, you can publish to GitHub directly. GitHub, in fact, if we look for Lodash in here, GitHub, Lodash, right? You can actually install Lodash directly from GitHub. Or let's talk about Express. So I'm gonna do that for you next. Express, not here. Express Express is a framework, a web framework that you can use to replace HTTP. So I'm going to install Express from GitHub directly. So the minute you push something to GitHub, it's available for people to use it with their Node project. So let's npm Express from GitHub. So when I do in here npm install Express, just like that, that will install it from the npm registry. It will not install it from anywhere else because I'm doing npm install. The default is the npm registry. But if I use this expression here, which is just express.js/express instead of Express, npm will detect that you mean go get Express from GitHub by default. This expression means, oh, this looks like owner/repository, so it must be from GitHub. So what exactly does it do? It will get the exact latest commit, the one that happens 25 days ago. So it will give you the latest and greatest of Express. So it's not the published package. So the final published package was in npm. If you go to npmjs.com and you look for Express, this is Express. This is the package that you get if you just install it directly from Express. And the final package was 4.17.1, and it is 25 days ago, so it looks like they match. But if someone pushed something to Express today, and then you did npm install Express/Express, you get the exact same commit that happened today, not the actual final published package. But this is how easy for you to get something from GitHub. So if you push your package to GitHub, you can get it. GitHub also has a package registry that they're working on, so you can install things from GitHub directly as well. But the package has to exist somewhere. You have to publish it somewhere, right? All right, cool. Good questions. Keep them coming. How does the repository validate the author's right to upload? Very good question. So you'll have to have some kind of authentication, and by default it asks you to log in. So you create an account with npm.js and you log in with an email and password. So if you do npm publish, you will ask you for your login and password. But you can also use SSH keys if you want to say, just like you push to a GitHub repository, and just like how GitHub validate that you have commit access to that repository, it uses SSH authentication. But you do need to authenticate somehow. And after you authenticate, because they know your identity, they're going to do the authorization. They're going to validate in their system, does this person have the right to push to this repository or to this package? All right, great questions. Keep them coming. So we were talking about import and export. So I think that is basically all the time we have to talk about Node modules and import and export, because we need to explore other things in the Node ecosystem. So if you have any questions about what we did so far before we move on, about all the import and export stuff, the require, the ECMAScript modules, the Node modules directory, package.json, and how these things work together, definitely now is the time to ask them. But otherwise, we're going to explore the HTTP package. So we're going to create in fact, I'm going to call it server.js. I'm going to create a server here. So I'll delete everything. I'll just keep server.js. And I don't really need any of those things, so I'm going to show you how to get rid of them. I'm going to just delete everything and just keep oh man, we have a lot of stuff that came from Express, but I'll show you how to clean this up. So what I'm going to do is I'm going to create a server, not here, sorry, in here we're going to create a server.js file, and we're going to execute the server.js file. So in here we're going to console log hello node, and we're going to execute. So what we're executing here is just oh man, node 06, yeah. All right, and I'm gonna just execute node-resm and server.js, and we're gonna actually create a web server in here, and we're gonna do it first natively with Node, and then we'll do it with Express. All right, so are we gonna talk, can modules be installed globally? Yes. So if you wanna install a module globally, all you need to do is npm install -g. So the -g flag means install this module globally. For example, I want to have a module to create a React project, or create React app. Create React app is a candidate for something that you want to have globally, because it just creates a React app for you. It's not really part of a dependency like Lodash or Express. You don't depend on it. You just use it to create something. Another module that is a good candidate for a global is ESLint. You want to have ESLint in all your Node projects, so maybe just manage it globally. Although it is probably a better idea to manage things locally, even for even ESLint, because you want to make sure that the whole team uses the exact same version and they don't depend on a global dependency. So I would avoid global dependencies unless it's a thing that you use globally for everything. It's a command, basically. Unless it's a command that gives you a binary executable command, just use local dependencies. So let me mention a few more things about package.json. We're limited on time, but I'll talk a little bit more about it. So one thing that you can do is use scripts. So probably the most important part of package.json for me in a big project is the use scripts. In fact, if we go, I'm going to show you a sneak peek into the package.json for the JS Complete project. So let's take a look at the package.json. This is the jscomplete.com. This is package.json for jscomplete.com. And you'll see that I have so many things under the scripts directory. See that? All of these are tasks that we use to run things at JS Complete. Some of them are development tasks, so things that we do for development, and some of them are production tasks, the things that we do for production. And these are different. So any person who works on the JS Complete project, they know exactly how to start a dev process. They know exactly how to bundle things for dev. They know exactly how to send all the JS drops emails, or update all the email templates, or log things in production. So these tasks are unified. We know we always have to do it this way. So how do we do that in our project? So let's create a task. So for example, instead of always doing node-r esm server.js, right? And if you bring someone new to the team, you have to tell them, oh, you have to use -resm in our project. Instead of doing that, you can have a start script. You can say, you know what? We're going to put this in a start script. So the start script is node-r esm server.js. This is how you start our system. And now it's a global knowledge, because all I need to do is npm start, because I can run the script directly, npm start. I don't have, and if you bring someone new to the table, they know they know to look for npm start, right? Because it's a global language. What can I do for this project? Well, you can start it, and boom, hello Node. It is running the -r esm server. So you will have a lot more in here. For example, what do we do to test things, right? Maybe are we using Mocha? Are we using Jest? Where do we look up the tests? So maybe that will be like, oh, just under ** test, or whatever things that you do. And now you can do npm test, and it will run Jest. Now I don't have Jest installed, so this will tell me what is Jest. I don't know Jest, but you get the idea. So these are special commands that you can do with just npm start and npm test, but they're equivalent to doing npm run start. So npm start is equivalent to doing npm run start. It's just a special one that has a shortcut. But in general, if you do something like, let's say I want to do it dev start, not just start, or prod. How do you start for production, for example? How do you start things for production? Well, in production, I'm gonna use I'm gonna use node env equal production, for example, and then do node-r esm server.js, right? So slightly different to run things in production than in development, right? So you have a different tasks for production run, and if you want to run this task, then you have to use npm run prod start, because it doesn't have a shortcut. So it's npm run prod script. In fact, these things are called run scripts because you use them with npm run. Cool. You can also use yarn. So if you're using yarn, Yarn is gonna run it. Yarn will find it. So you don't need to do yarn run. So it's a little bit different in how the package manager is using. So since I mentioned npx, I want to quickly talk about npx. So npx is npm execute, right? So let's say you want to npm install -g create react app. Create react app is just an example, so don't have worry about it. In fact, I'm going to use reactful. So reactful is just another one that I use. And if you have reactful installed, then you can do react new, I think, project. This is the command that you get. React full, not react. React full. So you get a binary react full new project, and it will create a react full project for you. So this is the command that you can use. But this will install react full globally and then use it, right? So a month from now, if I come back to the project and I do another reactful command, reactful new project 2, then it will install, then it will use the exact same reactful package that I installed a month ago. If I want to get the latest and greatest every time I use the reactful command, instead of npm install global, I can just use npx reactful and then invoke the command npx reactful new project. And what this command is going to do, it will install a temporary copy of reactful. So it will download a temp copy of reactful, use it, and then delete it. So I don't have a local copy anymore. Every time I want to use the reactful project, I can just download it with npx in one command, and it will download the latest and greatest and then use it, use the command that comes with it, because the command matches the package name. Cool? So this is npx, to install something globally and download it. But it's also available if you're in your project, if you have something that you need to execute. For example, let's say that we installed --dev. So I'm going to install -g. This is another thing that we need to talk about. And I'm going to install ESLint, right? ESLint. So -d means development dependency. It means we don't really need it in production. This is just in development. So if I do -d, it will put it not under dependencies, but rather under dev dependencies. You see that? So when you run things in production, if you have this production flag, if you have node env equal production, and you run thing with the production flag, it will not install the dev dependencies, right? It will just ignore them. It will only install the local dependencies, because ESLint is not something that you want to have in production. ESLint is a code quality check that will check things while you're developing them. But here's the thing. Just because we npm installed ESLint doesn't mean that we get to execute the ESLint command. There's no ESLint command. Where is the ESLint command? The ESLint command is deep under the node modules folder under .bin. So you can execute it from node modules .bin ESLint, and this will execute the ESLint command fine. So it's under node modules, right? Because npm just install things under the node modules folder. So if you want to execute it without figuring out where it is, or how to execute it, you can just use the npx command here as well, npx ESLint, and this will try to find it under the node modules folder for you. So npx is a handy tool to do that. That comes with npm. Of course, if you have yarn, you can just do the same thing with yarn. So yarn is just one command, and it will you do that. It will find the package for you. Now, if you put things in a script, so if here we do check, for example, and we do ESLint, npm is also smart enough to figure out that, so check in here, to figure out where to look for ESLint. So we can just npm check, run check, right? And it will also work as well. So it will execute the ESLint command. All right, so this is it. Dependencies, dev dependencies, and scripts. Very important things in package.json. If I delete a dependency from package.json, would it eliminate it from the project? Very good question. In fact, let's go ahead and delete Lodash, right? So if we delete Lodash, because we're not going to use it, it does not eliminate it from, by default, it's still under node modules. So the package.json file is just a documentation of what dependencies were installed. But Lodash is still under the node modules folder, right? So will it go away if I do npm install? So if you do npm install, it reads everything that you have in package.json and it gives you all the missing dependencies, right? But it does not remove the the dependencies that you do not depend on anymore. So this is just the npm. I think yarn behavior is different, but here's the thing: you should not really do it this way. If you want to kill the dependency, you should do npm uninstall Lodash, npm uninstall Lodash. So this will remove it from the node modules and it will remove it from package.json. So my advice is, do not touch dependencies and dev dependencies manually in your package.json. You can only change the meta information. You can add scripts manually, that's fine. It's just dependencies and dev dependencies, make them go through the npm command itself. Right? This is just the advice. Unless you want to change the this weird character here, the caret character, which means give me anything that is compatible with 3.3. So basically, so 3.3 would be fine here. 3.4 would be fine, but not 4. So it says, like, give me everything that is compatible with 3. So it might give you minor version as well. So if you want to change this and say, you know what, I want this dependency to be exact. Do not, when you update your package, always use the exact same dependency and not give me a new version, or give me just the patch. So there are like special meanings for all these syntax, but this is a bit advanced. These, you can change them if you want to. You can also just say star in here, which means give me the latest and greatest, even if it was ESM5. I don't care, just give me the latest. So major, minor, we call this, the semver string, and this is the semver version here. So major, minor, and patch. So you have to learn about semver and how to manage those. All right. So we'll go ahead and talk about HTTP next. So this is how you create a Node web server. You import HTTP from HTTP, and then you do http.createServer. So this API is from Node, http.createServer, and it's going to teach us a few things about Node. So what you get back from here depends on the API. So you can name it anything, right? In here you can name it anything. So you don't have to stick with the API. This name here has to be create server because that's the function the API exposes. But here we can name it anything. Usually I name this server, right? So this is the server, and you make server listen on some kind of port. So we make it listen on port 3000, for example. So this is the API to create a web server. Now, if you npm start, because that's the script that we put, if you npm start, you'll notice that Node did not exit. The process did not exit, right? I did not go back to the terminal command. And this is because of the listen. So if I kill the listen and run this again, it will create a server and then it will exit. I am back to the terminal, right? It did not continue running. So it is important for you to understand that Node will only continue running if it has a reason to continue to run, right? If it has a reason to continue to run. And that reason is, do we have any asynchronous calls that are listening? Do we have any handlers? For example, I can have a set timeout. Set timeout is a timer, right, that we can run, say, after 5 seconds. So it gives in here in milliseconds, and let's just do nothing, right? Set timeout after 5 seconds, just to keep Node busy for 5 seconds. So because there is a reason for Node to stick around for 5 seconds, when we run this code, Node will not exit for 5 seconds, and then after the 5 seconds, it will have no reason to stay running, and it will just exit, right? So that's extremely important. Node processes will exit if they don't have a reason to stay running. So for example, if in here, if we do server.listen, which is a reason for Node to stay running forever, right? Because it's listening, right? It's listening forever. So it's a reason for it to start to stick around forever. But if this listen function deep internally through an error, if there's an error, then that error is going to make the process crash and exit because there's no reason for Node to stick around. There's an error, so that process, the state of that listening server is unknown, so Node will crash and exit. So what does that mean for you in production? That means is Node by itself, the Node command by itself is not enough in production, because if you're just running a single Node process in production, that process might crash and exit at any point. So you'll have to monitor this process, and you'll have to have a cluster of processes, and maybe even a cluster of servers if you need to, so that if one process crashes and exits, another process is automatically started, because it is normal for a Node process to crash and exit. And if it has no reason to stay around, it will not stay around. All right. Now this server is listening when it will not exit unless there is a crash, an error, right? It will not exit, but it is doing nothing, right? It's just listening. There's no handler for what to do when an HTTP connection comes in. So this is an HTTP server, right? So there's no information about what to do when an HTTP connection comes in. So right now, it will probably say undefined if we try to access anything. If we go to localhost, and we go to port 3000, right? It will probably not do anything, waiting for localhost, and it will time out because there's no instruction. But here's the thing, the HTTP server received the request. It just did not handle the request. And the way it does this is through the events concept. So everything is handled with events. So when I hit that localhost port 3000 in the browser, the HTTP, the server object, is going to emit an event that says, oh, I received a connection. What should I do with it? So to handle the connection, I just handle the event. I do something like server.on, and I specify the event that I'm interested in, which is request or connect. I don't know what it is. I think it's request. We'll see. And in here you get you do stuff in here. So what do you want to do on request? Now, if you don't know what the event is, you can so here's the thing. If you're using a library like TypeScript, for example, which I recommend that you check out, then you'll immediately get all the discoverability of everything, because server is a typed object and we know all the events on it, we know all the stuff in it. But if you don't have this signature around, then just look up the documentation. Node API documentations are really good. So you just go to the Node API and you look for HTTP, and you look for .on socket, .on connect, you look for connect. There's a lot of in here, but I think what we're looking for is request, right? So you'll find that the request event here, right? And you can find examples. What is happening? This is the event request, right? And here's what you get when you handle the event request. You get a request object and the response object, right? And this is exactly what we're gonna get here. We're gonna get a request object and the response object. This is when I handle the request. So in here, you can do anything. You can do computations, you can go ask the database for information, whatever you need to do. This function here, which we call the callback function, but it's really more like a handler function in this case, is going to be invoked every time there is a request. Every time I put on localhost port 3000 and hit enter, that's a request, right? So let's console log request, and let's response.send something. So hello HTTP. So this is how you do it. Response.write, not send. Response.write hello HTTP, and then response.end. Now don't worry about the API yet. This you'll eventually learn, because these things, the response object here is a stream, so we need to stream information. This is why we needed to do .end for the HTTP protocol to say, oh, I'm done. But I want to show you that response.write. Now, we need to restart this process. Every time you change something in a Node project, you have to restart Node. Node does not have a development mode out of the box. So you have to restart it. And now, if I go to localhost port 3000, I will see hello HTTP. So the message that I wrote through HTTP. And note how I did all of this without any libraries. I'm not using Express. I installed Express, but I'm not using it. I'm just using the built-in HTTP library. Now, if you look at the terminal for the thing that we just did, you'll notice that we have two requests, not just one request. Although I refreshed the browser just once. I asked for that page just once. So for some reason, this handler is being called twice every time we request. So why? Well, you need to discover why. So to discover why, maybe you can print information about the request. Why am I doing this request? And I know that there is a request.url that you can use to figure out what URL is being requested. So now if we go back and we have to restart the server, remember we have to restart the server. If we go back and refresh the browser once and go back to see what requests are being made here, oh, check it out. So we're requesting that, and we're requesting the fav icon. So the browser is requesting the fav icon by default. That's Chrome, just trying to find the fav icon for that website. So you have to be aware of these things, right? That you invoke the request every time there is a request from the browser, and the browser might do requests internally for its own rendering. Right, an iPhone might request the Apple compressed icon for the tablet, and the Apple compressed icon for the iPhone. Right, it will request the 4 things actually. So you'll have to handle these. Right, now how do you handle them? Right, how do you say, oh, what should we do if the request is a fav icon request? We should serve a small image. So you would need to come in here and because of how limited this library is, you would need to come in here and say something, you know what, if the request.url is fav icon, then do something different, right? You would have to do something like this to handle routes, basically, right? Maybe in here, you just want to response.write, nothing. No, I don't have a fav icon. Else write hello HTTP, right? So now the fav icon is not going to get any response, where previously it got a string response, right? So you have to have extra logic to deal with routing, basically, because this is a very raw HTTP package that has no rich API for dealing with routes or dealing with files. What if you want to send a file to the browser, right? What if I want to go to like give me /a.png, right? If I want to get a file, an image, I don't have a way to do that. I have to use a different library to read the image from the operating system, and then write the binary information that I get by reading the image from the operating system into the response stream in here. So you have limited capabilities, but everything is possible. You can still do that. You can still read from the file system and use the Node response stream to write to it. But there is a better way for dealing with this, which is to introduce a library specialized in that kind of stuff, all the basic needs for you when you do a web server. And that library, the most popular library, is Express. So Express.js is, well, it's really a framework around web servers, and we all expect Node developers to be familiar with at least one web framework, and Express is just the popular one out there. So how to use Express? That's what we're gonna do next. But before we do that, you might see this handler written in a different way. Instead of server.onRequest, you might see it in here directly as a parameter to create server. So this is just a different syntax that you can use without dealing with the .onRequest kind of thing. so actually hides the request thing. But I don't like this syntax because I need you to learn that this is an event, right? And just like request, there are other events. There's connect and disconnect and many other events. And Node packages are really versed into this event nature. So everything is an event emitter. We call server here an event emitter. So and you probably need to learn your own event emitting skills. You have to be able to create an event emitter and listen to and make it emit events and listen to events, because this observer model in general, we call this the observer model. You observe something on something else, and it allows you to abstract your libraries so that they don't depend on each other. They just send messages, right? And you listen to messages and you react for messages. So this reactfulness in the observer model is really handy, and this is why it's all over the place in Node. By default, Node has a limited mechanism to handle asynchronous calls, which is the callbacks, and we should probably talk about it a little bit after in the third hour. I'm going to talk a little bit about callbacks and promises in general, because this is shifting from Node into modern JavaScript. But in the next 5 or 10 minutes, let's explore Express. So here's how you create a server with Express. Instead of importing from HTTP, we don't need HTTP. You import Express from Express. Now, what do you get here when you import Express? You get a function. So if you go to the source code of Express, you'll see that the top level import is a function, just like the function that we used when we were testing, the multiple calls. So if you want to use Express, and I'm just going to comment out everything here, just keep things just for Express. If you want to use Express, because it's a function, you just call it. And by calling a function, what you get back is a server instance. So basically just like the create server function. This Express function top level is equivalent to the create server function. All right, so the listen is actually exactly the same. You just listen on a port, so 3000, just like that. You listen on a port 3000, just like you did for the HTTP API. But the route handling is a little bit different, right? The route handling is a little bit different. So instead of doing server.on, you would do server.get. And this takes in an actual route.get/. And this will give you access to request and response, right? So it's similar to .on now, but it's now .get. So and you get access to request and response just like that. But you also, the response is a wrapper around the raw stream response that you get from Node. So in here you can do other things. You can do send or send file if you want to. This does not exist in the regular HTTP library. So in here I can even send an object if I want to. Send an object. So message is hello HTTP. So you see how hello Express, right? Because now we're in Express. So you have and you don't have to do response.end. Send is going to deal with this. So it will abstract some of these complexities in here. And also you get to be very clean in the way you define your routes, because now I can also do favicon.ico. In fact, I can do favicon.star. So if you call favicon.png, I'm going to respond to this route. There's like globbing going on here in the routes. So this, and in here, you would send file, the favicon, whatever the path to the favicon. So you send the file directly in here, right? And Express is going to deal with reading the file from the file system and streaming it to the requester. See how this rich API is really still basic, but it gives you some capabilities to just do features out of the box instead of having to deal with this complexity here. But it is a wrapper around the raw HTTP. In fact, what you get here, this listen method is just forwarded to the HTTP listen method, because Express itself is just a wrapper around the built-in HTTP framework that you get with Node. Now, we didn't really talk about the difference between import and export and require. There is a slight difference and that you need to be aware of, which is import is statically evaluated, while require is dynamically evaluated. So what does that mean? That means import is always top level. You can't, for example, import something inside another function. You can't do that. You can't import something inside a function. That is invalid JavaScript syntax. Why? Because import is statically evaluated, while you can totally require something inside a function. When if Node is wired with require, you can require something inside a function because require is dynamically evaluated and then cached. So that's a big difference between import and export, between import and require. Now, what if you want to dynamically import something with ECMAScript modules, not with Node? If you make the decision to use ECMAScript modules and you want to lazily import something, basically, you still have the option because there's an import function as well. So ECMAScript has an import function which behaves kind of like require in how you can dynamically call it, and it gives you back a promise. So what this gives you back is a promise. Now, this is how import is different than require, because require, although dynamically evaluated, it is synchronous. So require is synchronous, while import is asynchronous. So we're going to talk another 5-minute break and come back top of the hour and talk about synchronous and asynchronous, talk about callbacks and promises, and I'll go over some more of the modern features in JavaScript that you can use out of the box in Node, and it will make your code for Node better. And then we'll leave some time for questions because I'm pretty sure you're gonna have some. All right, so no, require is not really better than import, but it's just different capabilities. So if you want to have something synchronously imported, then you can have a wrapper around this import something. It's just require existed before ECMAScript decided on this import-export syntax, and its future is probably that it's gonna exist in Node, but it's not the way to go. But not for a few years. We still need a few years to stabilize this import-export. But I would say starting Node 14, no one is going to remember require. Everyone is just going to use import and export. And the reason is, this is going to work natively in the browser. So you can take the code as is, and it will work in the browser. And the browser is going to do the smartest thing to try to fetch things in parallel from locations. So you would have to import from an HTTP URL, of course. You would have to import from like github.com/express. And things will work just like that. And you don't need to bundle things, because right now when we ship things to a browser, we need to bundle them. We need to bundle them into one file so that the browser can understand them. But in the very near future, and by near future I mean it is possible already, but it's still experimental, but it's probably next year or the year after that, we will just ship the same code to the browser and the browser will work. All right, so what is bundling really quick? Bundling is when you take a front-end application that exists over many files and you pack them into a single file. We call this bundling. And then you ship a single file to the browser. So before we talk about callbacks and promises and a little bit more about events, let me tell you about, so if you want to, when you develop your Node applications, you're going to be editing files often, right? And having to restart things is going to get annoying really fast, because it's a running server, right? If you have a running server, so let's keep this running. A way to keep the server, any file running, is to do process.stdn.resume. Now this is advanced, but don't worry about it. So if I have a server that's running and I want to change things, having to restart the server is annoying. So what you can do is you can use tools to watch the files and trigger a restart on save, and one of them is nodemon. So we get npm install -dev nodemon for node monitor, and all you need to do is just switch your node command to use nodemon instead of node. So instead of node here, nodemon, and then it will auto restart things for you when you save the files. So now that we're running with nodemon, if I change the string and just save, it will automatically restart Node for me. So this is handy in development. So because otherwise it's going to be annoying, you're going to hate it. Of course, there are a few other tools. You can use PM2 itself. There's a forever npm package. So there's plenty of packages to do the thing. And this is general in terms of Node in general. When you need a single feature, you have a lot of options to pick from. For example, a web framework like Express, there are hundreds of them, not tens, hundreds of them, and every one of them has different advantages and disadvantages. So you're gonna have to make decisions on what libraries to use, and I would, and there are some guidelines on how to pick a library, but I would go for the popular library that is maintained and tested. So try to see if a library is maintained and tested, and it's responsive, that it's closing issues on GitHub, it's responding to issues on GitHub. And also take a look at the code. So don't be afraid of the code, and take a look at how the library is written. And are they using clean code practices? Are they using good things like TypeScript, for example? That's a good sign. If the library is using TypeScript in its code base, that means they care about types, they care about their API. All right, so this is nodemon. Now, let's talk about callbacks and promises. So I'm just going to kill this, restart. So it's a clean exit, nothing to do. And what I'm going to talk about is the callback pattern that you're going to see. So if you have a function that is wired for the callback function, let's use the execute command. So if you want to execute a command from within your Node process, you can use child processes, what we call the child process library. Child process. So this is how you use the child process. You just require, import, import something from the child process. And I'm going to talk about this syntax in just a little bit. So you import something from child process and use it. Now you have a few things that you can import from child process. I'm going to import the exec method from child process. So this exec method takes 2 arguments. Or 3, I'm not sure. We'll check the API if we need to. The first argument is the command to be executed. So let's ls/, right? This is the command to be executed. So I'm going to execute ls/ from within Node, and it gives you access to the output through a callback. So this is the callback that it will invoke. So in here you get a function. So the callback is just a function. I'm using arrow functions here, but you can use a regular one. And I think it gives access to out and error. I'm not sure. Maybe it gives access. So I have no idea what the API is, but the documentation to the rescue. So let's go look up child processes, and go for exec. What is the API for exec? Command, options, callback. So you need to get comfortable reading, by the way, this weird syntax that they use for documentation. So this weird syntax means this exec command takes the command, which is a string, and then it takes an optional options. So these square brackets around options mean they're optional. And also it takes an optional callback. And the options is an object, so you can skip it. The callback is a function, and these are the 3 arguments that you get: error, stdout, and stderr. I would name them exactly the same. So error, stdout, stderr. Right? These are the things that you get. Now, I'm not focusing about the API itself. What I want to focus on is the callback mechanism in here. So if I'm interested in the output, I just do stdout, right? So if I execute this file with npm start because it's wired with ESM and everything, then we will get module not found child process. Is it child processes? Child process. Oh, I misspelled it. So it's child process, and check it out. Boom! I see the ls slash, the output of ls slash. You see that? So exec executed ls slash, and then it gave me access to the std out. Now, if the command has std error, it will give me access to std error instead. But why do we have two errors? There's an error here, and then there is an std error in here. And the reason is, this error is related to the callback itself, not to the command, right? So it depends on how you deal with it. But the callback pattern in general is that there's always an error first argument. This is the callback pattern. This is what happens if we have an error in executing the command, not an actual error from std error itself, because every command might also result in an error, right? Every string that you pass in here might result in an error. In that case, you get an std error. But also exec itself might have an error. Maybe it's executing a command over SSH and network is slow. So there's plenty of ways for a command to fail. So you always get this error first argument, and you have to handle it, because if you don't handle it, the error is swallowed. It's not cached. It's not cached, and that means you have a bug. So because the command is going to continue to run, std out will probably be undefined and because you did not handle the error. So you always have to handle the error. What do you want to do if there's an error, right? What do you want to do if there's an error? And depends on how this module is used. You have to do something. You can, for example, throw the error. This is the safest thing you can do, is throw the error again, because if you don't, it's not cached at all, and it will just go silent. But throwing an error will make the error bubble up to the consumer of this module. You can also say, oh, you know what? If there's an error here, something serious it happened, and I don't know, and I don't want to risk it, I'm going to process the exit. I'm going to make the process crash and exit, because I don't know what happened. So I'm going to make it crash and exit with a status code of 1, which means this is not a clean exit. We don't know what happened. An error happened, and let's just crash and exit, because you don't want to have a process running in an unknown state. And when you get an error, you kind of have an unknown state because you don't know what the error is. If you want to handle some kind of error, you can have an if statement here that says, oh, if the error is this kind, one kind or another kind, if the error is file not found or command not found, I'm going to deal with it, right? But otherwise, process and exit. This is how you handle error. You should crash the process and exit, and then the monitor is gonna start a new process that does not have this error state. All right, so this is the error first. The error first callback signature is that the callback itself is the last argument to the host function. So we call this the host function, right? It might have a series of commands, and then the callback is a function that is the last parameter for that. The function is going to receive it. So it's the last parameter for that function. And then the callback itself has 3 parameters: error, std out, and std. At least one parameter, which is error. And then you get the data through the second and the third and the fourth parameter if they exist, right? So we call this pattern the error first callback pattern. And this is what existed in Node since day 1, and it's still supported today. But there is a different pattern today, which is to use promises instead of this callback mechanism. So if exec was a promise-based function, then this is how you would use it. You would say exec, and you give it the command ls, right? And this gives you back the std out, just like that, just as if it was not asynchronous. The reason we needed callback here is because exec is asynchronous. It needs to go to the operating system, instruct the operating system to do something, and then take results from when the operating system is done, which might be a few seconds later, and then do something with the results. So this is an asynchronous function. So it's not synchronous. I cannot do that. I cannot call it synchronously. I have to call it asynchronously. But if exec is promise based, then I can await, or first let's do dot then. I can do dot then. Yeah, let's just do await. So I'm not gonna, we don't have time to talk about dot then, and you should really just use await anyway. So you just await on exec, but to await on a function, you have to wrap it in an async function. So you would do, you would like define a main function, for example, and you label it as async, right? And then you call the main function, because this is async, so you cannot just await on something. You have to await on something inside an async function. But this is cleaner than the other part here, the other callback mechanism here, because callback has many problems, and probably the most famous problem is how when you start making operations depend on each other, you would have to start nest callbacks. So you would nest callback 2 in callback 1, you would nest callback 3 in callback 2, and we call this the pyramid of doom, you know, the callback hell problem. But that's not really the most important problem about callbacks. The most important problem about callbacks is that you lose control when you do things in a callback, because unless you have trust in the system, unless you have trust that exec is gonna actually invoke the callback one time, right? Then you don't have control. You don't know, exec might call your callback 5 times. I don't know. You don't have control over that. While here you have a little bit more control. You have a little bit more trust that this exec is a promise, and because it's a promise, it's gonna either resolve or reject. And it's going to resolve or reject only once. So by moving it into a promise-based API, you have a little bit more trust into how this API is going to behave. And this is especially important if you're using something that's not built in, not exec. If you're using something from Express, which are not built in. So you're really relying on the maintainers of the Express package, the people who wrote the code for the Express package. You're depending on their coding skills, right? And you never know. But if they give you the interface as a promise, then you get back a little bit more trust, because you know the promise is an ECMAScript, you know, a built-in JavaScript thing that is going to either resolve or reject, and it will do either of these once. So you have a little bit more trust. And also you have a little bit more control into the flow of the program. You get std out, and you can do something after std out. And if you want to nest dependencies, you can just do them inline. You don't have to nest callback functions. You don't have to do anything. So it's much cleaner and better way to just handle asynchronous in general. So here's my advice today. Unless you have to deal with something that only supports callbacks and nothing else, do not use callbacks. Always use promises. Now here's the thing, exec is not a promise-based function, so this will not work. If we try to console.log std out, it will not work because actually, no, it did not work. It gives me an error here, a big error, and I did not handle the error, right? You remember that I did not handle the error. So in here I got some kind of object, child process. It's not really the output that I'm interested in. All right, so how do you make it, how do you promisify this? How do you make it into a promise? Well, luckily Node has a tool. It's called utils, I think. So this comes built in, and one of the utilities, the utility functions, is promisify. So you can call utils.promisify, and you pass in exec, and it gives you back a promified version of exec. So we can make it like exec the promise version in here, right? And in here, since we have a promified version of exec, now we can use the promified version of exec, and things will work fine unless utils, is it util? Yeah, there you go. So we got std out. It looks like it returns back an object. So it's util, not utils. It returns back an object, right? And this object has std out and it has std error, right? So if you have an object like this and you want to extract the std out, all you need to do is destructure the std out, and now we're back into the same thing, std out. Cool. Now, what about std error and error? So std error is just another one. So if you want std error, you get it here, std error. If you want error itself, that's a special case, because now we're using a promise. That means we have to use the promise API to work with errors. So we can do that. We can do .catch in here because this is a promise, and this will give you access to the error. Or you can do the following. You can use JavaScript native error catching mechanism. You put everything in a try-catch statement. So you put your code in a try-catch statement, and this will give you access to the error that happens when you execute stuff. So in here, you would do something with the error. In here, you will process the exit if you catch something that you don't know, that you're unfamiliar with. Or just throw it again, report it, and throw it and ignore it, whatever you want to do with the error, right? So this API is better on so many levels. And again, the two main important levels here are trust and control. But also imagine that you want to do asynchronous calls in a loop. Like if you want to do a loop and every iteration of the loop, you have to do an asynchronous call. If you're doing it with callbacks, it gets ugly because you have to define the boundaries of your loop manually. You have to keep a counter and check the counter to do things in a loop. But if you want to do the asynchronous operation that is promise-based in a loop, all you have to do is just stick it inside the loop and things will just work. So there are many benefits. Now, some APIs are promised by default, right? So every decent library out there now supports promises, right? Including Node itself. Node itself is going to support promises. So you would do something like /promises, for example, and it will give you a version that support promises out of the box. Now they're working on that. The FS module, for example, has a promise-based API. So if you look up the FS module, which is something that you need to explore, which is how to work with the file system in Node. So if you look up FS in here, file system, how to read files and write to files and create copy files and rename files and delete directories. This is the biggest module in Node, right? And it is the most used module because we work with files a lot, right? But if you look at it, you'll see that it has a promises API. So you don't even need to promisify things. You get promises out of the box. And many other libraries support both callbacks and promises. They support callbacks for backward compatibility, but they also support promises because that's the direction where we're going with asynchronous calls. Now, if you notice, I didn't really use the promise API. I didn't do .then or .catch. I just used async await, right? Because it's just so much better. Then, so the promise itself gives you back the trust, but async await gives you much better flow control. So you flow your code in a better way. You control what happens with your code. So you don't need to nest functions, right? So there's much benefits to async await. So that is it about callbacks and promises. So if you have any questions about that, shoot them. Now, callbacks and promises, both of them really, are limited in terms of handling multiple events, right? Handling multiple events. So this is appropriate here because we have a single event. This asynchronous nature here is a single event that we need to execute a single command and get back a single output, right? But what if we have like a monitor of commands? What if we are monitoring the memory, for example, right? We're monitoring the memory this application is using. We would need to pull many commands on an interval. We need many events, right? Or we're monitoring the memory and we're interested in knowing what's going to happen when it reaches certain thresholds, like after 100 meg, 200 meg, right? So if you have an asynchronous operation that has multiple events, this is where you need to use an event emitter. You need to use an event emitter. And using an event emitter is straightforward because it's supported in Node itself. So this is something that you need to get familiar with. You import event emitter from events. This is also built in. You import event emitter from events, and you create an event emitter object using this syntax: new event emitter. And now you can emit events. You can say, okay, event emitter, I'm going to emit this event. Let's call it change. Something has changed. You can emit any event, right? You can emit the same event multiple times, right? And to listen on these events and do something, you just do the on method, just like the server, because the server is an event emitter. You just do on change. And what do you want to do on change? Well, let's just console log something has changed, right? Console log something has changed. So this is the syntax for event emitting, right? Now, here's your interview question. What's going to happen when I execute this code? And your answer is, will I see this 3 times because I emitted 3 times and then I'm listening to the onChange event? And the answer is no, you will not see it at all. Why? Because I started listening after I emitted the 3 events, right? I started listening after I emitted the 3 events. And the order here matters. So if we change the order to put the listen first, listen and then emit 3 times, then you'll see something has changed 3 times. So the order matters. In fact, everything here is synchronous. There's nothing asynchronous yet. However, what you can do is you can start emitting things asynchronously. For example, let's do a set interval and emit something has changed every second, right? Now we have a set interval that runs every second, and in here we can emit event emitter dot emit change, right? So in here, now what's going to happen is this something has changed is going to be emitted every second, and our handler is going to call it. Our handler is going to be called. So this is our handler, basically. We're handling this event by just console logging it, right? So this is what you use if you have multiple events going on. You would use an event emitter. And here's the thing. Everything in Node is based on this event emitter logic. So when you get an HTTP server or when you get a stream, right? They're all event emitting objects, right? So the you remember when we did server.get and we did that, and we did request and response, right? We did request and response, and we did something with request and response. Guess what? Server is an event emitter. Request is an event emitter. Response is an event emitter. They all have events, and you can listen to these events, and you can make them emit events, right? Can we make the emitter use async await instead of a callback? Yes, you can. In fact, this is supported if the not async await in general, but an event emitter is also can be consumed as a generator, because this ties into the generator concept in JavaScript, right? Because JavaScript has this generator concept. So if you wanna look that up, if you want any more information about that, look up generators in JavaScript and how to consume new event emitter objects in Node through the generator syntax. All right, so this is all the time we have for events. I'm gonna try to cover a few more topics in modern JavaScript, but definitely keep the questions coming because I know there's a lot of information here. I just want you to get a taste of everything that you can do in Node and really tease your knowledge into the capabilities that you have built in before even installing anything like Express or Lodash. The other big thing that you need to learn here before I switch gears into the modern JavaScript just review is streams. So you need to learn about streams in Node, and streams are big in Node. So what are streams in general? So streams are like, they're kind of like array of data, but instead of having this data over space, you have it over time, right? So it's not available all at once. It's not available for you in memory. You're just getting it over time. So every time you have a chunk, we call it a chunk, right? A chunk of data becomes available and you can use it in your stream. And after a while, you get another chunk of data and you can use it in your stream. So what are streams good for? They're good if you have huge amounts of data that you need to process in your code. If you need to process a huge amount of data in your code, you have to do it with streams. But here's the thing, here's the general advice I'm going to give you. You should just use streams all the time, even if you have to process small amounts of data, because you never know when the data is going to grow, and you never know what's going to happen in that case. So streams are basically just like pipes, yes, and you can pipe streams on each other. So an example of handling data that you should do through streams is the HTTP example for requester asking for an image, right? If a requester is asking for a file in general, you should really use streams to handle that. You should read the file as a stream and write the file as a stream. So when you do that, your application will not consume the size of the file in memory. So let's say you're trying to serve a 1 GB video file in your web server, right? If you don't use streams, you will buffer 1 GB of data in memory. And that's how much memory your node process is going to consume. But if you're using streams, you can get these chunks, 60 kilobyte at a time, or whatever the default chunk size is. And you get one chunk and stream it to the requester. And they get to play while you stream binary data because it's supported, right? Video streaming is supported. But this is how you do it. You stream it one chunk at a time. You do not send the whole thing. You do not buffer the whole thing. You do not send the whole thing. Now, Node comes stream ready out of the box. So the HTTP package is stream ready because everything is streams. And all the wrappers around it are streams ready. So when you do .send file, for example, in Express is going to do the right thing and stream it. You just need to be aware that you're dealing with streams. You're not dealing with buffers. You're dealing with streams in general. And when you run into problems, you'll run into stream-related problems, right? You have to be aware of that. So if you get any errors about chunks and stream interrupted, or one stream is slower than the other, right? Because if a stream is slower than, if the sending stream is slower than the receiving stream, then the streams have to do some back pressure kind of thing. So there's a lot of science around streams. You just need to know that you're dealing with streams all the time. You can also create your own streams in Node using the stream package that comes built in. And you also get streams out of the box. For example, there is the zip package, there is the crypto package that you get in Node, and these have functions that work with streams. So if you want to gzip something or unzip something, if you want to encrypt or decrypt something, you get to do it with streams, because all of these work on can work on large data. You never know if the thing that you want to encrypt is small or big. If it's bigger than a few megabytes, you should definitely use stream. This is why by default you should use stream. So there are a few types of stream, but the most important, the most interesting type is the transform stream. So there's read, write, there's duplex stream, but really the most interesting type is the transform stream, which is what you get when you use zip and crypto, is where you get one source, one readable source, and you write to a writable destination. So you read from a readable source and you write to a writable destination. We call these transform streams. All right, cool. The other thing that I want you to explore, and I'm going to give you some resources at the end for what's next, but the other thing that you want to explore is scaling in general. So how to scale a Node application? Because if you can't scale a Node application, you should not be running Node, right? Node has scalability out of the box, like built in. And the way it does this is through the cluster module. So the cluster module gives you a way to load balance a few processes together. And you should always run your Node application in production under a cluster. You should not run a single process. Even if your server is only capable of running a single process, that single process should be a cluster. So your server is gonna run as many processes as it has virtual cores, right? So for example, this machine, and we can look at the virtual cores here using os.cpus, which is a function, .length. So this particular Mac machine has 12 cores, right? Which means I can run 12 node processes and the operating system is going to be fine with it, right? And they all can run in parallel. So if I'm running a production server here, I would have a cluster of 12 processes, all running the same thing, and I would have a load balancer that balance between them. And the same process is going to monitor the 12 processes, and it will automatically start a new process if one crashes. And we can also do a zero downtime restart by restarting one process at a time. So we'll restart one process and wait until that process finishes any pending requests, and then when it's done, we'll start a replacement. So we call this zero downtime restart. So there's plenty of things that you can do, and you can do it all through the cluster module. But it's kind of like the story of HTTP and Express, raw versus rich API. So instead of cluster, you can use the PM2 package or something similar. PM2 is just one of my favorite packages, and this is what we use at JS Complete. It is a wrapper around the cluster module, and it gives you rich features out of the box with just a few commands. So definitely take a look at PM2. If you want to run a Node application in production, I would strongly recommend that you started with PM2. So let me just take a quick look at the big list that we started with and see if we missed anything important. I'll mention a few things here, but I kind of want to show you the inspection. It's important how you debug Node applications. So this is definitely on the list. But I'll mention a few things here. DNS, if you want to do DNS inquiries. Eval is something you should never use, right? This actually, it's JavaScript. Path, if you want to work with paths on the operating system. So if you want to look up a file, you need to specify a path. However, paths are going to be different on Windows than they are on Linux and Mac. So if you want to do it in an operating system agnostic way, you do it through the path module here. Readline, if you need to actually write a CLI command and you need to take input from the user, you can use this readline method. There are a few utilities that we didn't cover, but really util is kind of going away because things are coming natively to the language, right? So util was just a replacement, but there's definitely a few things that you can do here. What else? Crypto, domain, don't use that. Events, again, is the most important. Net, we didn't really talk about net, and net is big. So net, if you want to do any TCP programming in Node, if you want to do TCP communication and socket communication, you would use this built-in net library. If you want to interface with V8, you can use V8. This package V8 gives you a few methods to access V8 directly. Assert is something that you get out of the box, which is kind of like a very mini assertion library that you can use in your tests. So this would replace, this is just like Chai, for example. It has a few built-in assertions that you can use. FS is huge, right? This is the file system. OS is read information from the operating system. Stream, if you want to create streams, not if you want to use them. If you want to create streams, you would use this stream package. String decoder, if you are using binary information and you want to decode it into a string, you would use this one. Zlib, if you want to zip things and unzip things. this is all built in. You don't install anything. This is all built in power, right? Which is really great. Finally, query string and URL if you want to work with parse and format URLs. All right, so there's plenty of things for you to learn. You kind of have to learn like the capabilities of all these packages. And of course, I skipped everything JavaScript, but there's a lot of JavaScript in here. I want to show you how to debug a Node application. So let's say that we have an array, and we wanna a.map and like b equal a.map, and in here, let's say we want to function, and in here we want to return e times e. So some kind of code that we need to debug, right? And console.log b. So this debugging thing that I'm going to show you is going to work no matter what. Even if you have a server running, you can debug Node with the following. So if I'm running this server, node server.js, cool, things are working. So let's say we have a bug here, like we're plusing e plus e instead of star. We don't know like what is going on, and I need to debug what is going on. Why is it not doubling the elements why is it doubling the elements instead of squaring them? And I need to debug that. So what I can do is I can run Node with inspect. You just do node inspect, just like that. Node inspect server.js. Node -- inspect server.js -- inspect server.js, and this will run the file through the inspector. But this file does not run forever, right? Because it does not run forever, it will exit. So although we run it through the inspector, we also exited and the inspector exited. So what you can do is, instead of -- inspect, do -- inspect brk, which means inspect and break on the first line. So don't exit, inspect and break on the first line. So what this does is it will create a WebSocket server listening on this URL, and you can use a dev tool kind of tool to connect to this WebSocket and issue commands for Node to break on a breakpoint, or go to the next line, or go step over a function. The thing is, Chrome supports this out of the box. All you need to do is go to Chrome inspect, and it will see all the listening processes right here. So you see my node server.js, it's right here. All I need to do is click inspect, and it will give me, ready for it, dev tools for my Node script right there. And I can do everything I can do in the dev tools that I use with my front-end application. I can resume script execution, step over, go here, step into, inspect the variables, local, e in this case is 1, and then step next one, e is 2, and the return value is that. Everything that you have in the very rich dev tools experience, you can use it with Node just with the -- inspect or -- inspect brk. And you can set breakpoints and set expressions, call stack, watch expressions, everything, right? So how cool is that, right? Very, very, very cool. And every time you pause in here, you can do manual operations on the variables that you have. So this is inspection with Node. Just use the Chrome DevTools integration with the -- inspect. Now, if you need to inspect a Node application on like a server where you don't have a graphical interface, you can use the inspect itself. So if you just do inspect, not -- inspect, if you just do inspect, you get a terminal debugger. So you can debug here in the terminal, and you see how it stopped on the debugger line that I had. It stopped right here, and you can debug everything. You can go into, I think you can have to type REPL, and now you can debug things in the REPL. And you can type in, and you can control C to exit the REPL, type in help to see what you can do. In here, you can have commands to break points and continue and watch things and all this. So we call this a terminal debugger. And it's handy if you're debugging things in production on a server where you don't have a graphical user interface and there's a case where it only happens in that server and you can't reproduce it locally. So that terminal debugger is something that you can use as well. All right, cool. So there is a lot of modern JavaScript that you need to learn if you want to work with Node projects. And the reason you need to learn these modern JavaScript is that everyone is using them. So you look at any Node-based project, and the project that is gonna be, if you want to join a team, they're probably using modern JavaScript. Now, I wrote a lot about modern JavaScript. I'm gonna try and find the free article. So in the JS Complete library, I think it's JavaScript for React. All the JavaScript you need to use before React. So I wrote this for React, but it really applies to everything. So I am kind of like focusing on, and this is free, you can just read it here at JS Complete. I'm focusing on the features that are specific to React, but for Node, you need all this and more. So this is the whole subset that you need to learn. So I'm just gonna go over it really quick and just mention what's really important in modern JavaScript that you need to know. Block scopes are good, not very important. There we have the list here. Arrow functions, yes, we use this all the time. They are a little bit different, but what's important for you to understand is how they behave in terms of closures, right? So arrow functions and closure. And this article is your first good step into understanding these, but you're gonna expand on that after that. Literal notation, not really new, but we do a lot of stuff. Expressions, destructuring. Another big one here is destructuring. So I'm gonna quickly tell you about it. So this is the destructuring syntax that we have here. We use destructuring with arrays and objects. And so this is with arrays and this is with objects. Destructuring with objects. And it's really equivalent to doing these here. So the destructuring of arrays is equivalent to what I did here. You just take the items as they are positioned in the array, and you give them local names in the scope, in the local scope. You give them names in your local scopes. And that works for object properties and array items by their position, right? So very, very, very big. We use destructuring all the time because it's a much better syntax. You can also use it in function parameters. So you can destructure a function parameter. If that parameter is an object or an array, you can destructure the properties that you're interested in right there inside the function parentheses where you define the parameters of the function. All right. Spread and rest. The three dots operator, the three dots syntax here is magic. If you use it with destructuring like this, it's a rest operator. Basically, you're capturing the rest of the array elements after destructuring the first one into another array. So you use it to capture part of an array or an object, and you can also use it later on to spread an array into another array. So in here, the three dots operator is spreading array 1 into array 2 and introducing more items into array 2. And I'm spreading object 2 into another object. You spread one object into another object. Cool. So this is the spread syntax. Another important thing is promises and async await. So I told you a little bit about it. This is more details here about promises and async await. And we also talked about module import and export. A little bit more details here about named imports and named exports and default imports and default exports. And the rest of this article here is just not modern JavaScript, but more geared toward React. So in React, we use a lot map, filter, and reduce. We use conditional expressions. And if you need to use timers, you would need to use set time at and set intervals. There's some examples here about that. All right. So I do want to leave a few minutes for any last minute questions, but I'm going to give you a little bit more what's next. So this is not completely free, but I'm writing, but I think parts of it are. So I'm writing this complete intro to Node.js, which is going to be a mini book for for you to start with Node.js. It covers a lot of what we covered today in more details. So this is a good next step if you want to venture into that. And after that, I have the Node Beyond the Basics book, which is going to be a huge one. I'm still working on that, so it will hopefully be published in the next few months. But this is really the advanced book after you're done with just the basics. This is where you're actually going to learn Node. This is where you learn the modules and the event-driven architecture and the stream and the child process and how to scale with cluster. So deep dive into the Node concepts that we mentioned today. And there are a lot of them. There's a lot of details. Now, you can learn all of this through the official documentation. You just read the API documentation. In fact, this is how I learned stuff, is just by reading the documentation in here. And the examples are not too bad. It's just when you put things together and work through a context example that you relate to, it's a lot easier to learn. So that's what I'm doing in the next few months. Is I am fleshing out the Beyond the Basics book to have like one place where you can learn all the advanced stuff about Node runtime itself, not Node packages, but Node runtime itself. So I don't cover things like Express or Lodash or Socket.io. I don't cover any packages. I'm just focusing on what you get built in out of the box with Node and the capabilities that gives you, so you can build your systems on top of Node. Because if you can avoid introducing a new package to your dependencies, you should. So you should not really bring in Lodash just to sum an array, because you can sum an array in one line of code in modern JavaScript, right? So you should avoid getting a dependency unless like your whole system is designed around that dependency. For example, you're using React, you would have React as a dependency. But think so many times before you introduce a dependency, and if you can do it natively, you should do it natively first. All right, cool. So we're coming to an end, so I'm gonna leave some time for questions. So if you have any final last minute questions, now is the time. We've got 7 minutes left, so we can handle that. So I'll give you a few minutes to type any questions that you have, and I'll see which bits of JavaScript should you avoid in Node if possible. Oh man, that is a big question. So what should you avoid in Node? And the answer is there's nothing special in Node. You should avoid bad JavaScript. And JavaScript has a lot of bad parts, right? Now, modern JavaScript solved many of these bad parts, right? So you don't really have to deal with them. But you should, for example, always use strict, right? So this is one thing. So use strict is important. So if you go in here, by default, Node does not use strict by default. So I can define a variable without var, for example, and that's bad. You should not do that. You should not be able to define a variable without var, because JavaScript is going to do the hoisting thing and confuse your code. So this should not be allowed, and you can use strict in your files. Just use strict, and this will make the strict mode. This will activate the strict mode out of the box for you. But a better way to just adding this use strict everywhere is just to instruct Node to always use strict, and there's a flag for that. You can just do -- use strict, and this flag is actually v8. So if you do -- use strict and you try to define a variable without var, it tells you you cannot do that. A is not defined. What are you doing? If you want to define a variable, use var or const or let, right? So this is a form of protection against bad practices in JavaScript, is to always use strict. And if you're using a bundler, like for example, if you're using Babel, by default, Babel is gonna use strict for you. So, or if you're using TypeScript, for example, you can tell TypeScript to always use strict all the time. Assume strict mode, and TypeScript is gonna give you errors into using TypeScripts, into using non-standard or like bad practices. In fact, I would definitely advise you to explore TypeScript next, because TypeScript gives you a huge value, but the problem is it also comes with a lot of package for you, basically, that you need to you need to deal with types, you need to deal with missing types, you have to define, you have to write extra code. But give it a few weeks, not a few days. Give TypeScript a few weeks. And after a few weeks of working with TypeScript, you're going to see the value. TypeScript is next on my list of things to write about. So we use TypeScript at JS Complete, and it is a huge value for us. So in fact, my next Pluralsight course might be on TypeScript. And there will be in the future a book about TypeScript. So try to use the good practices and try to have a type checker in your system. But there's also ESLint. ESLint is big. So if you can't use TypeScript, if it's a big decision for you, just start with ESLint and start with recommended rules for your system. So ESLint is another code quality tool that you can use, and it integrates into your editor. So if you do something bad, ESLint is going to complain right away in your editor, and it can also auto-fix bad problems, some bad problems for you. So definitely take a look at ESLint and configure your system to have, you know, the recommended rules. Like, for example, a recommended rule is to always use semicolon. This is recommended rule. You should not write your JavaScript without semicolons unless you have in your flow something that will fix that most cases for you and warn you if you do if you do something like this, because JavaScript is going to assume you want to do that without a semicolon, right? So definitely ESLint is something that needs to be in your flow, even if you're using TypeScript, right? ESLint is just a different category of protection against what you should not be using in your code. So I'm gonna stop at this point. Thank you all for attending, and see you in other sessions.